At this example, we have a curling rock. It's sliding on ice, undergoes a constant acceleration of 5.1 centimeters per squared east. You might look at that and think twice about it, because curling rocks, as they're let go, they don't accelerate, they decelerate. Well, a deceleration is just a layman's way of saying it's a negative acceleration. And before I go and define the variables, looking at the direction of travel, it actually travels to the west. So a negative acceleration, a slowing down, is the same as an acceleration in the opposite direction. So we know acceleration, 5.1 centimeters per second squared east. Again, we need proper scientific units, so we would need meters per second squared, dividing by 100.051 meters per second squared east. The displacement, 28 meters west. Now, this also brings in another issue. Our acceleration and our displacement are in different directions, and that is not okay. We need to have them both towards the east or both towards the west. In reality, it doesn't matter. So since I have space under the displacement, let's change that to negative 28 meters east, because 28 meters west is the same as negative 28 meters east, vice versa. Anytime you're changing the direction by a full 180, you just flip the sign. We know this curling rock comes to rest. This is not VI in this case because the rock is slowing down and stopping, so this would be VF is 0. In question A, we wanted to determine the initial velocity, that is VI. And for this, we can go back to the same equation as example 2. VF squared equal VI squared plus 2A delta D. VF we know is 0. VI we're trying to solve for. A 0.051. Delta D negative 28. Working this out, 0 squared is 0. VI squared, we don't know. 2 times 0.051 times negative 28 would give us minus 2.856. We can add 2.856 to both sides. Square root. Now, this brings into question a mathematical operation. When we square root both sides in math, and physics is just applied math, we have to put a plus or minus with it. That plus or minus in this equation is there as a compensation for the direction. So we'll do the square root and we'll deal with the plus or minus in terms of the direction instead of assigning a sign to the velocity. We take the square root, go to 2 sig figs, we get 1.7 meters per second. Now, common sense would tell us, since this curling rock is traveling 28 meters to the west, that the VI must be towards the west. Going on to part B, the time of travel. I'm not going to redefine the variables, A, delta D, VF, VI. They're all the same as they were before, but now we are trying to solve for delta T. At this point, we have many of the equations we can choose from, but it's always better to go with the simpler ones if we can. The simplest one that we can use for this is VF equal VI plus A delta T. Before we get there, though, I am just going to recap. VI, which we solved for, was 1.7 meters per second to the west. VF is 0. A was 0.051 meters per second to the east. Sorry, meters per second squared. We do still need to account for the direction, and we will need to flip one of these. I'm going to flip A just because I have the space with it. So that would be negative 0.051 meters per second squared to the west. Flipping VI to negative 1.7 meters per second to the east would do the same thing. We just need to make sure that all of our components are set in the same direction. So doing the math, VF was 0, VI 1.7, A negative 0.051, and delta T we don't know. Moving the 1.7 over to the left, we get negative 1.7 equals negative 0.051 delta T. Divide both sides by negative 0.051, going to 2 sig figs, we would get 33 seconds.